Hello and welcome. In this video, we will explore one of the core concepts in relational databases, joins in DBMS. In real-world database design, we normalize data into multiple related tables. But when we want to retrieve the data meaningfully, we need joins. Joins help us combine rows from two or more tables using a related column, usually a foreign key. There are different types of joins: inner join, left join, right join, full outer join, cross join, self join, natural join. Let's explore each of them with definitions, syntax, and examples. Inner join, definition and syntax. Let's begin with inner join, the most commonly used type of join. An inner join returns rows when there is at least one match in both tables based on the condition provided. If there is no match, the row is excluded. Syntax: select columns from table 1, inner join table 2 on table 1 dot column equal to table 2 dot column semicolon. This join is perfect when you want only related data, for example, finding student who belong to a valid department. Inner join example program. Here is a real example. We have two tables, student in brackets SID, comma, name, comma, department ID. In department table in brackets department ID, comma, department name. We want to list student names and their department names. Select student.name, comma, department name from student, inner join department on student.department ID equal to department.department ID semicolon. This query only returns students whose department ID matches one in the department table. Left join definition and syntax. A left join returns all records from the left table and matched records from the right. If there is no match, nulls are used for the right table columns. Syntax: select columns from table 1, left join table 2 on table 1 dot column equal to table 2 dot column semicolon. It's helpful when you want to show all entries from the main table even if there is missing data on the right. Left join example program. Let's look at left join in action. Select student.name, comma, department.department name from student. Left join department on student.department ID equal to department.department ID semicolon. This returns all students including those who don't belong to any department. For such student, department name will be null. This is useful for identifying students with missing department data. Right join definition and syntax. Right join is the reverse of left join. It returns all records from the right table and the matched records from the left. If there is no match, nulls are used for left side columns. Syntax: select columns from table 1, right join table 2 on table 1 dot column equal to table 2 dot column semicolon. This is helpful when the right table is more important and you want all its data even if unmatched. Right join example program. Here is an example of right join. Select student dot name, comma, department dot department name from student. Right join department on student dot department ID equal to department dot department ID semicolon. This returns all departments even if no student is assigned to them. It helps detect empty departments or orphan record. Full outer join definition and syntax. Full outer join returns all rows from both the tables with nulls where there is no match. Syntax: select columns from table 1, full outer join table 2 on table 1 dot column equal to table 2 dot column semicolon. This gives a complete picture of both tables, what matches and what doesn't. It's great for comparing data sets and identifying mismatches. Full outer join example program. Here is an example. Select student.name, department.department name from student. Full outer join department on student.department id equal to department.department id semicolon. This returns all students and all departments, whether or not they match. It is ideal for reporting and audits where no data should be left out. Cross join definition and syntax. A cross join returns the Cartesian product of two tables. Every row from table 1 is combined with every row from table 2. Syntax. Select star from table 1, cross join table 2 semicolon. If table 1 has 3 rows and table 2 has 4, the result will be 12 rows. Use this join carefully. It can create a lot of data. Cross join example program. Let's see a cross join example. We have product in brackets PID, comma P name and store in brackets SID, comma H name query. Select star from product cross join store semicolon. This lists every product in every store. It's useful when we want to show all combinations of items and locations like a sales plan. Self-join definition and syntax. A self-join joins a table with itself. It is used when rows in the same table are related. For example, employees and their managers. Syntax. Select A dot column, comma B dot column from table A, comma table B where condition semicolon. We use alias A and B to differentiate the two instances of the same table. Self-join example program. Let's look at this query. Select A dot name alias employee, B dot name alias manager from employee A, comma employee B, where A dot manager ID equal to B dot EID semicolon. Here we get the name of each employee and their corresponding manager by joining the employee table to itself. This join is often used in hierarchies or recursive relationships. Natural join definition and syntax. A natural join joins tables based on columns with the same name and data type in both tables. It is automatic. You don't specify the on condition syntax. Select star from table 1, natural join table 2 semicolon. Be careful through it joins on all matching column names, which might. Why use joins in DBMS? Let's summarize why joins are so important. They combine data from multiple tables, help you retrieve complete meaningful data, allow efficient and flexible querying in real applications like banking, inventory, or school systems. Joins help present full information without duplicating data. Visual representation of joins. To better understanding joins, let's visualize them. Inner join, intersection of both tables. Left join, all from left matching from right. Right join, all from right matching from left. Full outer join, union of both, even unmatched. Using Venn diagrams can make these concepts very clear. Performance consideration with joins. Joins can impact database performance. Here is how to manage it. Index your join columns to speed up access. Filter early using where classes. Avoid joining too many large tables without necessity. Optimizing joins is key in handling large data. Join conditions and aliases. Always specify your join conditions clearly. Use aliases for cleaner, more readable SQL. For example, select A dot name comma B dot department name from student A, join department B on A dot department ID equal to B dot department ID semicolon. This shortens your query and avoids confusion in large queries. Joins versus subqueries. When should you use a join and when a subquery? Joins are better when combining rows. Subqueries are helpful when one result is needed for another query. Joins are generally faster and preferred in most reporting tasks. Common errors in joins. Here are some typical mistakes in joins. Missing on condition leading to huge data sets. Accidental cross join from forgetting where or on. Mismatched data types like joining a string to a number. To avoid issues, always check your join logic and data types. Conclusion. To conclude, joins are powerful tools in SQL for retrieving relational data. Each join type, inner, comma, left, right, full, across, self, natural, has its own use cases. Understanding them makes your queries cleaner, more efficient, and more powerful. Thanks for watching. Don't forget to subscribe for more database tutorials.